fast to switch screens. I can try it myself. I can do it. I can do it. I can do it.
Click the Windows key and switch over to PowerPoint.
Okay, that's good. Um, okay, hi everyone. Go brains. A little bit about schizophrenia and other conditions. However, we have a guest speaker who's going to be coming in next week and then sharing his research expertise on melanoma and skin cancers as well as brain tumor cancers. And so to situate you a little bit and to make sure that you are all able to follow along with this lecture, we had to take a little bit of a pivot. We will come back. This is also on your final exam, but we needed to talk a little bit about skin and then to understand some of the different structures or review some of the structures in skin. For me, it's actually a really fascinating topic because there's a lot of things going on related to skin, and it actually is a little bit of an equity issue as well. And as I mentioned at the very outset in this course, there's a lot of equity in health and disease, but there's also a lot of inequity in health and disease, and I'll point that out to you as we kind of go along. So the other thing I'm going to ask you to do is we need a little bit of help. So I'm going to ask for your input into like what format of the lecture notes you'd rather prefer us using. So this is like the traditional lecture notes. Some of you liked the Cornell style with the notes on the side. Some of you didn't like it. I just need to know what's better for you as a class going forward. So if you can like email me or let your TAs know whatever is more comfortable for you, that would be great because we just need like one standard template moving forward. The other thing I'm going to ask for your help with is one of my ROP students is currently doing a research project. She needs a little bit of help on a survey on how you take notes. So I'm going to put the link up on Quarkus. If you wouldn't mind filling that out, it would be a great help for her. It also will help us to understand how we can improve our lectures to make sure that you have really good notes that you're able to study from. Okay, so you don't have this slide, and it's okay, and we are doing the full recording and full stream. What are we looking at here? Any guesses? Sorry, I think I heard something. Anything? Any synapses? Does kind of look like that, right? Kind of looks a little bit like neurons, kind of looks a little bit like synapses. Anything else? Any other guesses? Melanocytes? Why not? Okay, sure. Any other suppositions. So whether you think so or not, your skin cells, even though we know a lot about skin, and even though you'll be hearing about research at sick kids about melanoma and childhood melanoma, and other forms of melanoma, one of the things that I want you to understand is we still don't know a lot of the processes that help us have different skin types or cell types within the skin. So one of the things that is really interesting, what you're looking at here are actually calcium waves that are occurring within certain groups of cells. And there are actually two different types of cells, and this is just to orient you so that you understand why we talk about them. There are two major cell types that we're going to be looking at in our lecture today. One are keratinocytes, which make up the vast majority of your skin in different layers. And the other one is actually the melanocytes, the ones that will form the melanomas, the skin cancers that you might be thinking of. And it turns out that when you have them growing in culture, that they actually signal a lot like neurons do. So it kind of does look like neurons. And one of the things that we are seeing here is the activation of different melanocytes, which are sitting nearby these keratinocytes. And as the keratinocytes, which we can't see, as they release substances like acetylcholine, which is a neurotransmitter, or endothelin, it activates these melanocytes. So in this picture, we see like this really big one here at the top. We see another one kind of mildly activated. And so we're just understanding now in 2020 a little bit about how different groups of cells in these different populations in the skin, how they communicate with each other. So it does look a lot like neuronal transmission. And so we're always trying to figure out new things related to skin. So I'm going to take you through different aspects of what you need to know. And I'm hoping that you'll get your exam schedules out pretty soon. But the exams are probably a little bit on the earlier side for this course, just to let you know without giving away too much. And hopefully you'll get that full schedule out. But this is going to be included on your final exam as well. And we're going to be doing a lot of discussions today around keratin. And I'm not sure, did my mic just go out? Okay. So we're going to be doing a lot of discussions around this molecule keratin, why it's important in these different layers of your skin. And because of the way that skin actually just comes off and is shed, so my wife likes wearing makeup. I don't think that she needs it. You can tell her that. But one of the things that she does is she wears makeup and literally she is applying chemicals to like dead substances on her skin, right? So I keep telling her it's a waste of time and money, but if that makes you happy, go for it. Your skin does a lot of things, which is what we're going to be talking about, and then we'll talk a little bit about some of the histology and why my mom actually tried to tell us a lot about skin when we were younger, but I never listened to her, and I might be paying the price for that down the road. So again, none of this is important for you. I'll tell you when we need to start taking down some notes. So skin is an area of research that we don't really talk a lot about, which is one of the reasons why I'm really interested in getting Dr. Sidaway to come in and talk about his research and his interest in melanoma. And we know, for example, that there are lots of different stem cells that we can either grow from skin or we can use skin to actually develop other skin types and even hair follicles, which is, again, really, really interesting if we think a little bit about this. One of the areas in which you have probably heard a lot about machine learning and AI is in health and disease. And one area where we know that it's going to actually be really, really important is in the diagnostics around skin, as well as different types of carcinomas on your skin, so skin cancers. There's a problem, though, because there are actually apps that are available that you can download, and you can take a picture of your skin or put your cell phone camera up against your skin. And what do you think is the problem by self-diagnosing? Even though it's like an app, and it's an app that's been downloaded like many, many times, do you see any potential problems? Yes. So misdiagnosis, and do you think it's an underdiagnosis where you're missing things or you're overdiagnosing? Yeah. So it turns out that there's a worry right now from the United States Dermatologists Association that there's an underdiagnosis by using these apps. Like you've taken a picture, it says that it's not a melanoma, but in fact it could indeed be a melanoma. But we think eventually down the road, artificial intelligence is going to be able to recognize enough patterns to be able to correctly diagnose not just skin cancers, but like things that are different forms of tumors. And so there's a lot of research going on in terms of AI, skin diagnosis, et cetera. And again, we also want to understand a lot about skin grafting. And so we need to sometimes be able to replace skin, especially after burns. And there's a lot of research around all of these different areas. So I think that if you were to take a look, you don't have to be a clinician, that if you were to see someone with any of these pre-existing skin conditions, that you would probably tell them, yeah, you should probably go see a doctor, you should probably get that looked at. And these are the different forms of skin cancer that we'll be looking at. And then next week, you'll be hearing about the melanoma from Dr. Sidaway, and this is sort of his area of research. But we could have things like basal carcinoma. And when we start talking about the different skin layers, you should be getting a good idea of like what types of skin cells are involved. We could have squamous cell carcinomas. And again, these are very serious conditions. And of course, the ones that we're the most concerned about, things like melanoma, because melanomas are most easily spread to other parts of your body through a variety of mechanisms that you'll hear about next week. So again, no problem making these sort of diagnoses, but here's the thing. If you were to look at these skin pictures, and again, this goes back to a lot of apps or taking pictures of your skin and then trying to come up with a machine learning process where they are trying to make a call as to whether or not there is any issues. Do you think there's a problem with someone's skin here on the left? Looks pretty good. Slight discoloration, maybe? Maybe? How about over here? Would you be too concerned by this little patch of skin that's discolored? I'm sure we all have like little patches of skin. And here, we have a discoloration. It probably looks a lot like a melanoma, and it kind of looks like it's more like a rash, or there's a rash associated with it. And it turns out that all of these are indeed in the same order. This is actually a form of basal cell carcinoma, squamous cell carcinoma, and this is a melanoma. These are all diagnosed as such, but it's hard sometimes to make these calls, and so we need to understand. Just for your own information, when we take a look at skin cancer, we have the two different types that I just showed you, basal cell carcinoma, squamous cell carcinomas. These are generally treatable if they're not too far progressed. Again, one of the big issues in terms of why is the United States Dermatologists Association concerned? If you catch it early, there's incredibly good recovery from these types of non-melanoma cancers. But if you think everything is okay and you're not getting treated and you're leaving it too long, then it becomes an issue. And then, of course, these melanomas. And of these melanomas, 1 out of every 2 types of cancer is one that involves the skin. These are the more serious types. And it also shows that we are seeing a really big rise in the number of people that are affected with these different forms of skin cancer. So it's not just about having more apps available. More people are getting diagnosed by dermatologists. There is really an increase in skin cancer and the incidence of skin cancer here in Canada. Again, the numbers not being really important, but if we're looking at the non-melanoma types of skin cancer, the vast majority, the basal cell carcinoma, squamous cell carcinomas, more than 95% of them can be cured if they are detected in time. Now, just a little bit of a caveat. These numbers actually are there for Caucasian background individuals, and the numbers are very different if you're looking at racialized individuals, especially if you're looking at darker skinned individuals. These numbers are not reflective of that statistic, and in fact, it's harder to make that diagnostic call on individuals that already have pigmentation within their skin. And we need to talk about that because we need to understand that there might be an underdiagnosis of a lot of these different forms of skin cancer. And again, if you take a look, the proportion of patients that actually develop a second skin cancer after 5 years actually is still fairly high. It's on the order of about 40% of the population, and that's mainly due to exposure to the sun. And that's, again, something that we need to be concerned about as well. So all of these numbers suggest, and this number to me is like spectacularly interesting. I don't know if you have ever visited a dermatologist. Not all dermatologists are licensed to be able to perform a procedure called the Mohs procedure, where if you detect skin cancer and you're trying to remove it, there's a precise way in which this is done. There are only 15 licensed individuals in all of Canada. In fact, in Toronto, we have like a really large proportion of all of the dermatologists that can actually perform this procedure. So I think we have about 3 or 4. So within Toronto ourselves. So dermatology as a field is a great place to get into. It's one of those things that I'm hoping that if you're interested, you can chat with me. There is a clinic at Women's College Hospital that is completely devoted to dermatology. We are happy to send students there if you're interested in doing some shadowing. So it's more of a clinic, so you're not going to shadow like one individual, but if you're interested in any of these practices, please let me know and we'll be happy to set you up with that. So what we're going to be talking about today is skin cancer. We're going to be talking about the different cell types that are involved in skin, how we can develop skin cancer, and then you'll hear more about the mechanisms next week, and then the following week we'll come back and revisit some of the basic biology as well. But most of this is due to exposure to the sun, and so we need to keep in mind a lot of the things that are happening. So again, the statistics are actually kind of out there. Some people agree, some people disagree. Most dermatologists kind of suggest that even if you have one severe sunburn, and I'm sure all of you have had sunburn where your skin has turned red and then it's kind of peeled off. And if you had that during early childhood or during adolescence, you can actually dramatically increase the risk of skin cancer. And again, most of you protect your skin as much as you can, but if you haven't done that in the past, then it means that you've already have increased the possibility or the risk of developing a form of skin cancer. And it doesn't only have to be on exposed skin or direct exposure to the sun. Melanomas can also start to form where your skin is not directly exposed to the sun. So not just having like short sleeves and shorts, you can also have it like under your clothes as well. So these melanomas are actually really important. So here's where I'm going to ask you to start taking down a little bit of your notes if you need to take down any notes. Most of it will be what's already presented here for you. In the next, this slide and the ones that come after are the ones that are a little bit more important for what you need to know for the final exam, as well as for the upcoming lecture. So most skin cancer is induced by different forms of UV radiation. Most common in fair-skinned individuals as well as the elderly. Again, there's an immune component to this, which is what I'll come back to a little bit later on. The most common form of skin cancer is that basal cell carcinoma. Are we concerned? Not so much, because if you are detecting this early enough, most of it is curable. 95% of this early detection leads to a cure, and 5 years later, like, there will be no incidence of skin cancer, this basal carcinoma type. And this arises from cells within the stratum basale. And I'm going to use a couple of different terms. So stratum just referring to like the layer, and then the basale meaning like the lowest or basal layer. And I'm going to use some other terms like the stratum germinativum, and I'll make sure that you know that these are equivalent. And if we have cells that are starting to undergo mutations, they will go from the basal layer and they will actually go into another layer underneath, which is not part of your skin, but which is part of the dermal layer. So this can be treated fairly easily by surgical removal. as well as radiation, focused radiation on the area of skin that is affected. And so again, this is a form of skin cancer that we'll be looking at today, as well as a little bit on squamous cell carcinoma. This is the second most common type of skin cancer as well. This is going to arise from the keratinocytes that are found within the stratum spinosum. They can, again, if you leave it long enough and you're not getting it treated early, this is a non-melanoma type of skin cancer, so getting early diagnosis, early treatment, perfectly fine, great recovery rates. But if it's untreated, it can spread or metastasize to the lymph nodes, and from the lymph nodes, it can spread to other parts of the body. So if you're not getting it treated, this can actually become lethal as the skin cancer spreads. And one of the areas it can spread to is actually into the brain, and this can happen for a variety of reasons. And I think Dr. Sidaway is going to talk a little bit about that as well. The malignant melanoma, the one that you hear the most about, this is the most deadly and most aggressive form of cancer. As the name suggests, within your skin, we have embedded within it, on the lowermost layers, we have these melanocytes. And these melanocytes help to give skin their coloration. And oftentimes we have like these little patches of skin where we have more pigmentation. So you might have a mole, which is, in the medical term, it's called a nevus or a nevus, the plural form being nevi or nevi. And so we have these. They're part of our skin. But if they change shape or they start to become asymmetrical, these pre-existing moles, or they start to have different coloration. So if you see a mole and some parts of your mole start looking darker than others, that's a coloration issue. And then if it starts growing in size, and if it grows over 6 millimeters, then it might be an indication that you are developing a melanoma, and you should get that treated as quickly as you can. And then elevation, what do you think that term refers to, elevation? So the asymmetry is no longer like a nice round shape. And the previous example was a really great one. Sorry to do this. I know you hate it when we go back in these slides. But this is very asymmetrical. It's not, we have like these little patches that are kind of like sticking out. So this asymmetry is one of those signs. If you go back to that picture, you'll see that the borders are also very irregular. It's not like a well-defined border. There are little patches that seem to be growing out. Elevation, what do you think that means? So what's it doing? So it's growing upwards, right? So it's kind of elevating and becoming a bump on your skin. So all of these suggest that you should probably get that looked at early, and checking your nevus, your moles, frequently is always a good idea. And again, there are a great number of Canadians, and this is a few years old now, there are a great number of Canadians that actually are diagnosed with melanoma. And if you think a little bit about that, this again is primarily through skin exposure. Something happens to the melanocytes. These melanocytes become, they start to grow and start to divide aberrantly. Males tend to get affected more than females overall, but those numbers are always in flux. And so we're seeing that it's not quite as big a distinction as it used to be 3 or 4 years ago. And the numbers of males and females, they're kind of becoming a little bit more equalized. And if you look at the number of new cases of cancer compared to like lung cancer, breast cancer, etc., skin cancer is indeed like the cancer that is being diagnosed much more frequently. And it is the number of new cases of skin cancer dominate the other forms of cancer. So it's something that we should be interested in, health and disease, and it's something that we should understand a little bit more of the biology. Again, those numbers on that previous slide, not important. So up until now, the only slide I want you to kind of concentrate on is that overview slide of like the different forms of cancer, like the basal cell, squamous cell, and melanoma, about 2 slides back. So another way that we often talk about skin is the integumentary system. So if you see the integumentary system, it's referring to skin. We use it for protection, for excretion. A lot of it is for temperature maintenance. We store a lot of different nutrients in our skin. I'm going to talk to you a little bit today about vitamin D3 synthesis, as well as, of course, most of our cutaneous receptors, the ones that tell you about pressure, about what's pressing up against your skin, they all exist different layers. And all of you have had a physiology course, right? So sensory physiology, right? Again, you don't need to worry about memorizing anything on this slides, just to orient you a little bit. So in today's lecture, because you'll need this for next week and the week after, we're going to talk about the different layers within the epidermis. Then we'll come back and talk about each of the different cell types that are affected in basal cell, squamous cell, and melanoma. And then below that, we have this dermal layer. And the dermal layer can actually be separated into two other layers, which is the papillary layer, which is superior. And then below that, or inferior to that, we have the reticular layer, all part of the dermis. And then under that, we will also have this hypodermal layer, which is often referred to as the subcutaneous layer. And those make up the three major layers of the skin. Hopefully all a review for you. Any questions on this before we get going? We're good? All right, so when we look at skin, we have two major definitions of skin, and it's not that big a definition or a big shift in the definition. So we have thin skin, which is like 4 layers thick, and I'll show you the different layers in a moment, or 4 strata thick. And then we have thick skin, which is 5 strata or 5 layers thick. And again, just to orient you, this is the layer that we're talking about. The epidermal layer, we're not talking about the dermal and the subcutaneous layer. Those are separate and distinct. Here in this layer, we either have 4 layers or 5 layers. Okay? And again, the skin is providing a lot of mechanical protection, as well as preventing fluid loss. And of course, nowadays, we're very concerned about the transmission of different types of viruses, different vectors, and these microorganisms, if we didn't have this skin, would be able to penetrate much more easily. And you can actually see the H&E stain here on the right for thin skin versus thick skin. As the name suggests, it is literally thicker. Where do you find thick versus thin skin on your body? Thin skin. Where is your thin skinner? Skinnier. Sorry, skinner. All right, nice. Yes?
Do you feel like at your fingertips where it has to be very sensitive?
Fingertips, more sensitivity because you have more sensory receptors in terms of density on your fingertips. It's a good guess. Anywhere else? Yes, Omar?
I think thick is in the palms and the soles.
Sure, for sure, yeah. But where do we, and nothing wrong with that definition. We definitely have thick skin, palms of your hands, soles of your feet. Where else do we have thin skin, though? On your back? Nope. Good guess. Yes, way at the back. Sorry? Your lips. In certain places, yes, but the one place where you have like really thin skin is like on your eyelids. So your eyelids are where you have like really thin skin, only 4 layers thick. Most of your other places on your body, some places on your lips, you could have thinner skin, but we have like 5 layers generally throughout most of our body. So I hate to do this to you, but it's one of those really deep dive slides. There's a lot to memorize on here. I'm going to try to focus you a little bit on what types of things that you need to know. The one layer that's missing and is not found in thin skin is this layer here, which is called the stratum lucidum. So here is where we have 5 layers. So this is thick skin. Thin skin is the same, except we're missing this layer, the stratum lucidum, and thin skin does not have this extra layer. So if we were to start from the most superficial layer, or the very top, the one that's exposed to air, and we work all the way down into the deeper layers, where underneath this basement membrane we would have the dermal layer. And without referring back to your notes, how many layers of the dermis do we have? We have 2. Do you remember the uppermost superior layer? The reticular layer is top or bottom? Bottom, and the upper one is papillary layer. Awesome. Okay, so here at the very top, superior, we would have the stratum corneum. So that layer is something I'd expect you to make sure that you know. There's a lot of keratin within the stratum corneum, but this is literally where you have a dead layer of skin. We have the stratum lucidum, again, another dead layer of skin, but it has very specialized molecules, including the keratohyalin. You'll also be able to see other things in the slides that are coming up after this, but this particular layer is unique to the thick layer. Another layer is the stratum granulosum. We also have keratohyalin here, but here in this particular layer, we actually see it inside granules, ready to be secreted, ready to be released, and particularly inside these cells. And these lamellar bodies, again, are also part of this stratum granulosum as well. Underneath that, we have the stratum spinosum, and we'll talk a little bit about the stratum spinosum a little later on. And this last layer, the stratum basale, this is where we actually have dividing cells. So it kind of makes sense that when we talk about cells that are dividing, and when they're dividing too much, and when we talk about basal cell carcinoma, and when we start looking at where they're found, these cells are already taking part in division anyways, in this bottommost layer. And then as they start dividing and as they start moving upwards, they will start forming these other layers as they go along. So if we were to take a look down here at this layer, the stratum basale layer, you don't see all the cell types. We'll see other cell types coming in a moment. From your other lectures, if you've taken HMB322, the histopathology, what makes the basement membrane unique? Why do we want basement membrane? What is one of the things that it helps to do? Anyone? Yes, Amy. So attachment, definitely, 100%. In addition to attachment, what else does it stop from happening? Yes? So you're going to have to speak up just a little bit. Okay, so it could be a physical barrier to stop the metastasis, but in fact, I've already told you that some forms of cancer can metastasize into the dermal layer. So one of the things that it acts to do, as long as cells that are dividing are in contact with the basement membrane, the basement membrane is also there in many tissues to actually regulate mitosis. So you don't get an overproduction of dividing cells. So just keeping in mind these 5 different layers, and if you need a little bit more time to memorize, this is one of those slides to circle, to come back to. I can guarantee you this will be on your final exam. I'm not going to ask you to draw this, but you should definitely know the different layers and the characteristics that are associated with it. And this weekend tutorial, you'll come back and revisit the most important slides from this lecture as well. So these different layers within your epidermis, so we just looked at 5 layers, so this is just a conglomeration of all of the different 5 layers. One of the things that's really important is this keratin, and this keratin and the cells that are dying, that are accumulating keratin, are shed, but this molecule is really important. And one of the things that you'll see, not just having a basement membrane, but if you look at the very bottom of the epidermal layer, you'll actually see that they have ridges. So it sort of has this sawtooth-like pattern. And it's actually really important because with the papillary layer, the dermal papillae, the ones that actually project upwards, interlock with these epidermal ridges. And so they allow you to have like fingerprints being formed. So that's why you have these ridges. You can see these ridges on the top of your skin in the form of fingerprints. And these are, again, important for improving your gripping ability as well as others. So the uppermost layer, the stratum corneum, you can have up to like 30 different layers of dead, scaly, as well as keratinized cells. So they have lots and lots of keratin, but they're not dividing anymore. They're not having any cellular functions. And these are usually removed. And of course, some of you will have experienced like flaky skin after like getting a sunburn. So your skin starts to peel. It's because all of those skin cells that are there, they die off like much more quickly, and you will form this sort of peeling skin pattern that you see here. So again, I just covered a whole bunch of slides. I didn't really pause to take any questions, or if you had anything that you weren't sure of or needed some clarification. Do you have any questions, clarification at all? No? All right. So this gets into the stratum lucidum. So I mentioned that the stratum lucidum, we only see this in thick skin. I mentioned that we have molecules like keratohyalin. And one of the things that makes the stratum lucidum kind of unique is that we also will find in here this other molecule which is related to the keratin, related to the keratohyalin, and the precursor molecule in this particular layer that's only found in the thick skin and is characteristic of this thick skin is known as elodin. And this elodin actually does not pick up most stains really, really well. And so no matter what kind of staining you do, whether it's like standard H&E or whether you're using different forms of like Luxol Fast Blue or others, you don't really see this layer staining, and you get this nice sort of translucent layer that doesn't pick up any of the histological stain. And again, this is packing the keratinocytes, and the cells in this layer are not the ones that are going to be producing the keratohyalin through the granules and releasing it. So in this layer, even though we have a lot of elodin and we have a lot of this keratohyalin, we're not actually producing it here. It's just part of the milieu. And these cells that are here actually don't have any organelles. They don't have granules. The layer underneath it does. Okay, so stratum lucidum, important. All of these characteristic features of these different layers are important for you to make sure that you know for your final exam. All right, so the layer underneath that, or inferior to that, is the stratum granulosum. And these are the 3 to 5 layers of flat keratinocytes, and they're flatter if you look at it morphologically, or if you were able to stain them, and then you were able to look at them under a microscope. And these, again, contain keratohyalin, but we actually see secretory granules. So the previous slide, there are no granules, completely agranular. We might see keratohyalin, and that was on like the previous slide. But here, we actually see them in granules ready to be released. And so we also will see intermediate filaments within the skin that are used to convert granules to forming keratin. So these are intermediate filaments. These are not microfilaments, so there's no like motors associated with them. So microfilaments like actin, which is what the MF stands for, microfilaments, there are no motors, like tubulin is not there. There's no motors to help with the movement of these different granules. Particular to this stratum granulosum, we have a lot of lipid-filled vesicles, and this is used to waterproof your skin. So if you had an issue with your stratum granulosum, your skin wouldn't be able to kind of repel water the way that it normally does. It's really because of this layer and having lipid-filled vesicles that also convert to glycolipids. So these lipids in these vesicles help to form these glycolipids that waterproof your skin, and it becomes a really important layer for us to be able to exclude water from entering our bodies. All right, so this last layer, second last layer, the stratum spinosum, there's a lot on this slide, and I don't expect you to memorize everything on here. I'd like you to keep a couple of things in mind, though, for when we start talking about this in future lectures. So if we look at this layer, so this is the stratum spinosum. Under that, we have the stratum basale. Haven't talked about that yet. It's the next slide that's coming up. If you were to take a look, we do have some immune cells that are found within these layers. So we'll have, for example, these Langerhans cells. So these were originally derived from these macrophages. These macrophages can actually cross the basement membrane, infiltrate into the skin, and they will convert to these Langerhans cells that are part of this stratum spinosum. So we do have immune cells as part of our skin, and it's actually really important that we have these immune cells within our skin. And the vast majority, if you were to take a look, the vast majority of these immune cells are actually within the dermal layer. So again, just keeping that in mind. And if we look at the next layer down, the stratum basale, we will have a T cell. These T cells are specifically CD8 positive T cells. And then I'll talk about this melanocyte in a moment. We have a lot of these. Your skin is actually an immune reservoir, so we have a lot of these immune cells. We have about 800 of these immune cells, like the Langerhans cells, per cubic millimeter of skin. If you don't have them, one theory that has gained a lot of popularity is that this is one reason why you might actually have an increased incidence of skin cancer in some individuals, because their immune system is actually being suppressed. So early detection of aberrant pre-malignant cells by these dendritic Langerhans cells might be a way to clear any malignancy before it develops. So again, really interesting. I'm not sure if Dr. Sidaway is going to talk about it next week or not. If he doesn't, then I'll come back and talk about it the following week. All right, so I think I'm just going to go through this one slide, then we'll take our break if that works for everyone. And this, again, is a really important slide as well. So make sure that all of these different layers, the main features that are associated with these layers are ones that you go back and review. You'll get part of that again in your tutorial this week. And in tutorial this week, you'll also be given some more instruction about your upcoming presentations, and you'll also be drawing for the order of your presentations. So make sure at least one person in your group is able to show up for your tutorial. So in this stratum basale, another word for this stratum is also the germinativum. And I use these terms interchangeably. They're the same layer, so right above the basement membrane. So this is sort of a single layer of cuboidal or very small, low columnar, so almost cuboidal looking cells that are sitting on the basement membrane. On the previous slide, I showed you that we have a lot of mitosis that's going on within this layer, and this basement membrane is important to keep that mitosis in check. So we have in this layer, for the most part, these cuboidal cells are these keratinocytes. And these keratinocytes are undergoing mitosis, and usually they're pushing their way upwards. So way upwards. These keratinocytes we've seen like in almost every single layer of skin that we've looked at so far. Also, another cell type that we haven't talked about directly in the stratum basale or the germinativum, we also have these melanocytes. These are the ones that normally cause skin coloration. These are the ones that synthesize melanin. And then they distribute melanin and release melanin from their processes so that your skin is also like receiving melanin. It's not just kept within the melanocytes. And this melanin that gets released from the melanocytes gets picked up through endocytosis by the nearby keratinocytes. And we think this melanin is really important because it helps to shade the nuclei from UV radiation. And if any of the skin cells are not appropriately shaded by this melanin and their nuclei are in direct contact with like UV radiation, they can develop a number of mutations, and we'll talk about those today. And this is where the beginning of mutations that lead to squamous cell or basal cell carcinoma or even melanomas can begin. Also on this layer, we have these Merkel cells, which are part of the touch receptors, and these are right at the basement or right at the bottom of this stratum germinativum. Okay, so again, we just talked about a whole bunch of things. Do you have any questions or things that you just want to clarify, confirm that you need to know, not know at this point in time? No? We're okay so far? All right, so what I'd suggest we do is we'll take a 10-minute break. So if you can take a 10-minute break, come back, and we'll get going with the rest of the lecture. one last question. If is anyone missing a pair of AirPods? Okay. If you might have dropped them, this is your AirPod case. They're up here at the front. Okay, everyone, so a couple of things while we're waiting for a few students to come back from break. Make sure that you have like a good paper, that you have at least read through the introduction, the last part of the introduction, because that's where you usually find the hypothesis and what they're really looking for. Make sure that you've read through at least the first part of the discussion, because that's like their major findings and whether or not their conclusions were accurate or not. So if you can do that and you're comfortable with the topic of your paper, bring it to your tutorial like on Thursday. You'll have like a fairly brief overview of the important slides from this week. You'll have an opportunity to talk to your TA about the presentations. You'll also be drawing for the order or talking about the order of presentations in the last 3 classes within March. So again, making sure that you're all set is like really important for this week's tutorial. So I'm going to talk to you a little bit about melanin and a little bit about these melanocytes. So we're looking at a cross-section of skin here at the top. And then what we're doing is looking at this sort of box here. And what we're looking at is sort of a cartoon version of what we are seeing here. And you can see like the really dark pigmented skin, cells down here on the bottom. And if we were to take a look at that in a little bit more detail in a cartoon version of that, this would be that melanocyte that we've been talking about. And this melanocyte is the cell type that actually causes skin pigmentation. In response to UV radiation, it will produce more of melanin. Melanin is then released from these different appendages, and this melanin pigment is taken up by the surrounding keratinocytes that you see around it. If you go back to that earlier video that I showed you at the beginning, that you don't actually have in your slide deck, these are the cells that were responding. So they're also not just giving melanin to the keratinocytes, they're also responding from signals that are coming from the keratinocytes, which is why you saw them flashing brighter colors or flashing whiter colors earlier on. So that sort of interplay between keratinocytes and melanin is not just that one way that I wanted or that I'm showing here. I wanted you to make sure that you understood that it is a two-way communication that we were looking at. So if we look at these melanocytes in a little bit more detail, so we form melanin from the amino acid tyrosine. So it's taken up by these cells. The amino acid tyrosine is then used to eventually form this melanin. So there are different versions of melanin. So there is eumelanin. So this is often found in skin as well as in hair. And if you have eumelanin, a specific isoform of melanin, you will actually have these darker colors, which is the process that you're seeing here. So this is like usually a darker brown color or a black, darker pigment. If you have pheomelanin, again, all from the same amino acid tyrosine, this is often found more often in women. It's also found in both skin as well as in hair. And this leads, depending on the amount of it, to more of a reddish pigment. And you can see that the more of it you have, it's more orangey red. And if you have less of it, it will actually be more of a sort of a yellowish tinge to this. These melanosomes are actually transported by both anterograde as well as retrograde transport mechanisms. These involve the microtubules. So these are microtubule-associated proteins. Kinesin for anterograde transport out to the processes, and then we can recover some of these different melanosomes through a retrograde dynein-mediated fashion. And I'm assuming that you all remember your first year biology classes for the microtubule-associated proteins and how we get the transport of these granules. So we have other pigments beyond melanin. So if you're thinking, well, okay, so black-brown, yellow to kind of reddish color, we also can have different pigmentation through other molecules like keratin. So it's not just sort of, we have eumelanin, pheomelanin. Keratin can also help to color your skin as well. And we've just talked about all of these different types of pigments in the previous slide. And all of this is taking place and it's being released from cells at the level of the stratum germinativum. So these melanocytes, they don't move. They're stuck in this lower layer. So here it's stratum germinativum. I've also called it stratum basale. So they're stuck in the lower layer. And if you're wondering why they have these long projections, because they have to release melanin to these upper layers. So keratin is also something that can be used to color skin. It's also sort of a yellow-orangish pigment in addition to sort of the pheomelanin. We often see it in different types of vegetables. This tends to accumulate more in the stratum corneum, so the uppermost layer. We see a lot of keratin deposition. And keratin can also be converted through processes I'm not going to get into vitamin A as well. So we have many different types of pigments, and there are more beyond these two molecules that I'm mentioning here that lead to the whole spectrum of different skin colors. So again, just to make sure that we're all sort of on the same page, the other layer below the epidermis, so inferior to the epidermis, is this dermal layer. We can further subdivide the dermal layer into the papillary layer and then the reticular layer, also highlighted for you here. So the papillary layer is important because we have a lot of different blood vessels that are associated with it. We have lymphatics that are associated with it, so lymphatic vessels. And we also have other sensory nerves of the epidermis working their way up through this layer and embedded just underneath the epidermal layer, which is what you are seeing here. Underneath this, we have the reticular layer, and this is a network, and reticular just means a network or a mesh. And this is a network of collagen as well as elastic fibers. It gives you your skin's ability to kind of bounce back. So when you press down, if it doesn't bounce back, it's a problem with the reticular layer. And we'll often find that we have arteries sort of at the base of this layer as well. And right at the border between the subcutaneous layer and the reticular layer, we have these different arteries and major or other blood vessels. And we have some other sensory receptors for light touch as well as pressure. But again, those aren't the major things that I want to emphasize. Any questions on this slide before we go on? Yes?
The arteries on the subcutaneous layer, where are they in the papillary dermis?
So we have them right sort of at the border of the the reticular layer, and then we have, these are the major blood vessels or arteries, and then we have the smaller branches of them coming up here. Okay. And again, the major blood vessels right at the layer between subcutaneous and this reticular layer down here at the bottom. Any other questions, things to clarify, confirm? No? All right, so this bottommost layer is this hypodermal layer, and this hypodermal layer or subcutaneous layer has a lot of loose tissue, so it's areolar tissue. It has a lot of this adipose tissue as the subcutaneous layer tends to have. It's also fairly elastic as well, and only the topmost portion, right at the interface between the reticular layer and the subcutaneous layer, is where we have these arteries as well as veins. If you're thinking back to that earlier slide that I showed you before, where we're looking at the immune system, and we were looking at the immune system, and we were looking at all those different cell types that I told you you don't need to worry about, and we had many of them, so macrophages and a number of other immune cell types. It makes sense that they're there because of the rich blood supply and lymphatic supply to this particular layer above it. So again, really important. I didn't mention it at the time, but this rich vasculature is important in delivering a lot of those immune cells. Oftentimes, if we want to make an injection, and you hear about a hypodermic injection, it is made into this layer because we do have that interface with these major blood vessels that we see running through it. So it is vascular. It does receive a lot of blood supply, and we do start to see these arteries and veins starting to appear. So again, just in terms of some of the things that the skin can do, So one of the things that we know that skin is important in is the formation of vitamin D3. And again, it's a little bit controversial. I know some of you have learned about multiple sclerosis, and I know some of you have learned about multiple sclerosis recently in the neurobiology course. But there's a lot of controversy about this. So one thing is multiple sclerosis much more prevalent in northern climates or things outside of the equator where there's not a lot of sunlight and not a lot of UV light? And there definitely is a correlation. So many countries north of the equator and then south in the southern hemisphere, south of that, do tend to have a higher incidence of multiple sclerosis. Canada, because we are a northern country, actually has a very high incidence of multiple sclerosis. And some of the thinking and ideas around this is that somehow vitamin D3 produced by the skin in response to UV light, and we tend to think of UV being detrimental and a cause of cancer, and it definitely is. So don't get me wrong, it is. But do we need to have like UV exposure or sunlight in order to be healthy? And one possibility is your skin needs to be able to produce this vitamin D3. The epidermal cells within the stratum spinosum, as well as in the germinativum or the basale, help to convert a cholesterol-related steroid into cholecalciferol, also known as vitamin D3. And the liver then gets involved in this, and it will convert this cholecalciferol into an intermediate product. And so we need the sunlight working on these epidermal cells within the spinosum and germinativum to form vitamin D3. There's also some evidence to suggest that vitamin D3 levels, the more it falls off, the higher the incidence of multiple sclerosis. So there's sort of an inverse correlation, but it's not 100% verified, because what would you do if that's turned out to be true? So if it turns out that there is a correlation between not having enough vitamin D3 and developing multiple sclerosis, what's one obvious solution that you would do? Yep, Emily?
Increase like how much you go to the sun.
Yep, you could. In the winter it's hard. We don't have like really good sunlight, and we don't get direct exposure, so it's possible. What else could we do? Vitamin D3. Yeah, Omar? Could use supplements, and there's a lot of literature that says that taking supplements could help and might prevent multiple sclerosis, especially in northern climate countries like Canada, Scandinavian countries. But there's also a lot of evidence that says it doesn't help at all. So the jury is still out on that. But we do know that vitamin D3 is important. It forms different important hormones, and it's important for the kidneys to help to synthesize calcitriol, and calcitriol itself is also really important for calcium reuptake from the small intestine. So by not having vitamin D3, are you going to affect other hormonal systems? Yes, but how much of that is actually due to direct sunlight exposure? So any guesses? Like, how much vitamin D3 does your skin produce in response to being out in the sun? Like enough that you'd be able to form like a vitamin tablet. 500 to like 1,000 IUs, international units of vitamin D3. Is that how much you would produce? How long do you have to be out in the sun to do that? Any guesses? So imagine like you're out on the beach and you're lying there in the sun. You've protected yourself, but you're still being exposed to sunlight. And you have most of the UV radiation, the bad stuff, because you're being protected, but your skin is still being exposed to sunlight. How long do you have to be there to produce enough that you'd be able to form like one tablet or 500 to 1,000 international units of vitamin D3? Yes? A few hours? No, you'd have to be there a long time. So you'd have to be there for a couple of days. So again, the data is very out there in terms of, does vitamin D3 actually cause a lack of vitamin D3 produced by your skin, especially in the winter? Is this why we have so much multiple sclerosis in Canada? It's a very interesting hypothesis. Is there a correlation with decreases in vitamin D3 and multiple sclerosis? There seems to be, but why don't supplements help, and like how long do we have to be exposed to this? So it's a really tough sort of health and disease type of question. So again, just switching gears a little bit, but still talking about the stratum basale. One of the factors that is really important, remember there's a lot of mitosis that's going on within the stratum basale or the stratum germinativum. I told you I'd use the terms interchangeably. In order for these cells to divide, not only do they not have to be in, or not as bound by the basement membrane, but they also need like epidermal growth factor to help them undergo this mitosis. And epidermal growth factor not only helps with mitosis, but it also helps with the production of this keratin. It's important because if we need to be able to accelerate skin repair, epidermal growth factor, or EGF, is believed to be really important in that whole repair process as well. So I'm going to just show you this next slide. We're not going to worry about all of the different cell signaling pathways that you see down here. In fact, some of these are molecules you've seen before when we talked about insulin receptor. The idea is exactly the same, by the way. So here we have the epidermal growth factor receptor. So we have one subunit of the EGF receptor, and here's the other one. And it dimerizes, just like we saw with the insulin receptor, in the presence of EGF. It will also do that in the presence of like TGF alpha, but we won't get into that particular pathway. And when it dimerizes, it causes a cross sort of phosphorylation that then allows for all of these other intracellular molecules to start accumulating, but we're not going to go into any of these pathways here. I'm just setting it up so that when we talk a little bit about HER2, and we talk a little bit about HER2 in cancer, we have a little bit of a framework of what EGF receptors are about. These receptors are found primarily in the stratum basale or in the stratum germinativum, and it's important in the mitotic and the synthetic pathway in the cells that express these. So any questions before we go on, or anything I can clarify for you now? No? All right. So we're also going to be switching after the next series of lectures into a little bit about bacteria and its impact on health and disease. We'll talk about the gut microbiome and the skin microbiome sort of as a transition. On your skin, we have a number of different bacterial species that are there all the time. One of these is the Propionibacterium acnes. These are gram-positive rods. And I believe most of you have taken HMB322, so gram staining, you guys are all aware, gram staining, gram-positive, negative. Know the difference between rods and causi, everything else, okay? So one of the things that this is important for, on your skin, one of the things that is produced by different types of skin that we'll get to a little bit later on is this substance here known as sebum. So sebum is sort of that oil that forms on your skin. And these bacteria that grow on your skin actually like to digest and use this sebum. And one of the byproducts of the Propionibacterium as it digests this sebum is a substance that actually attracts neutrophils to the area. And especially if you have an area of your skin that's part of a pore where you have these Propionibacteria growing, you have a lot of oil in there, it will actually attract enough of the neutrophils that they will start to digest these bacteria, and sort of the white substance that's left over, the pus that's left over, the whiteheads that you might see developing are because the neutrophils' digestive enzymes have tried to digest the cell bacterial walls. And so is having acne a sign of health or disease? Physiological or pathophysiological? Is it normal or not normal? Or is it a little bit of both? What do you think? So let me ask it a different way so that when we come back to and talk about the skin microbiome, do you know anyone who has never had like acne? Like you have like a friend who just like always has like completely clear skin? A couple of you? And do you also have friends who like break out whenever they're stressed out? Right? So we're going to come back and talk about this, but actually it's the type of bacteria that you have living on your skin that actually makes a difference in terms of whether or not you could have this breakout of the of skin acne. And again, for some individuals, it is pathological because they do produce more sebum, and they have this bacteria. So it's not just sebum, the oily substance produced by some skin cells. It's also the fact that they have the wrong type or too much of this bacteria around. You need both to occur. There's a lot of debate about this as well. So going back, we wear cosmetics on our skin, not just females, males do as well. So these oil-based cosmetics were originally thought to worsen like having like breakouts, but we now know that's not necessarily true. It depends on your skin type, the type of bacteria, how much sebum that you're producing, whether or not these oil-based cosmetics are actually plugging more of your skin pores. Again, there's a lot of debate because I know some of you are asked by people in your family, so if I eat chips, will I break out? You've never been asked that question? Like if you eat like junk food, will you break out more? Like you've never been asked that by anyone? So does diet affect whether or not you produce like more sebum and then you produce like having more like acne? There has been no study that conclusively shows that diet actually directly affects like being able to have more acne or not, but stress has been shown to be able to affect the level of acne formation. And for some individuals, it becomes a mental health related issue. And for those individuals, it's not just waiting for the acne to clear up. They will have to take some drastic action to kind of make sure that they don't have that for like, psychological reasons. So some of these different treatments that are used will include things like benzoyl peroxide, so just drying out the skin. Some of you will know that many of the skin cleansers actually have mild acids like ASA. Same thing that you have for aspirin, like it's also in there. Benzoyl peroxide just dries out the sebum completely, so no sebum, and it'll also kill off some of the bacteria. You don't produce this acne. Sometimes tetracycline, which is an antibiotic, can be applied to skin. We don't take tetracycline by mouth because it can actually affect the osteoclasts and osteoblasts and discolor bone. But tetracycline can be applied directly on the skin and can kill off the propionibacterium. And Accutane is used as well. So if you have no sebum, you don't really have an issue with bacteria. And this is a form of an isoretinoid, very similar to vitamin A. And we talked about vitamin A and carotene, vitamin A, etc. This is usually taken orally, but all of these are very, very drastic steps for individuals that are really bothered by their appearance, and it becomes like a mental health related issue. These are not things that you can buy easily over the counter, so you can't buy tetracycline, and the benzoyl peroxide that you can get over the counter, it's not at the concentration that you can get from a pharmacist, and Accutane is only available by prescription. So these are only in cases where an individual is really, really at risk because of mental health related issues. So we'll just talk about some skin markings, and then we'll talk a little bit about the mechanisms behind skin cancer. I'll set up what will be coming up in the next lecture, and I think we should be done in the next 15 minutes or so, in case some of you have to leave a little bit early. So these freckles and moles that many of us have are really just a conglomeration out through your skin. There's a small concentration that we have as a patch, and if they're really small, they could be a freckle. In a larger collection, it could be a mole. And these melanized patches are usually flat, so they're not elevated. And this mole or a nevus or nevus can become elevated a problem. And this might suggest that there's some malignancy. I also wanted to talk to you a little bit about hemangioma. And these hemangiomas are actually tumors, but they're benign tumors. Because we've been talking about the different layers of the skin, so epidermis, 5 layers or 4 layers, and then we have sort of under that we have a dermal layer, and then under that we have the hypodermis or subcutaneous layer. We can often see birthmarks, so often these are like red colored, and these are patches of discolored skin, and it's not due to melanocytes. These are actually because we have an abnormal collection of dermal blood capillaries. And these hemangiomas or birthmarks, some people call them wine stain discolorations. Sometimes they disappear in childhood. Sometimes these hemangiomas are there throughout the person's lifetime. And depending on the type and the size, these hemangiomas can be called capillary hemangiomas if they're relatively small. If they're bigger, they can be called cavernous hemangiomas. Again, it's just like more blood flow, more capillaries found in an area in the dermal layer. And if it's a fairly wide patch, it could be the port wine stain. So it's just a discoloration of your skin. It's not in the epidermal layer, it's in the dermal layer. And it's just because we have an abnormal accumulation of blood vessels or these capillaries that we have in this dermal layer. So again, another form of these skin markings. So I'm going to take us through really quickly how we can develop these different types of alterations, what could lead to having basal cell carcinomas or squamous cell carcinomas or even melanomas. And I'll tell you like what sorts of things you need to concentrate a little bit more on. So again, the wavelengths are not really that important. I don't need you to memorize like the different wavelengths. So we have like these 2 major types, which many of you are familiar with because you've read sort of the sunblock at the back. So UVA or UVB. And again, it was thought up until about 5 years ago that we should be blocking UVB radiation. That was the bad thing. Now we're kind of worried about both, so UVA and UVB. So it doesn't really matter like whether one's better for tanning or not. Both are thought to be really harmful for skin. And if you've ever looked at someone who has a sunburn, have you seen anyone that's had like a sunburn and it gets like really red? Right? So what causes that? It's because we have increased blood flow to that area. So you physically have damaged your skin, and you know that it's actually due to increased blood flow. How do you know that it's increased blood flow? What do you love doing to someone that you know has like a red sunburn? That's right, you do exactly that. Thank you. So you go up behind them and you smack them like where they had their sunburn, and where you've hit them, you know that it goes clear, like it goes white. All the blood has like flowed out, and then it comes back to being red because blood flows back in. So it's literally you're damaging your skin, and as a result, there's increased blood flow to that particular area, which is why your skin looks red. So this extra blood causes that redness. But please don't hit your friends if they have a sunburn, because it's really not, it's not a nice sensation. So I've just indicated this in advance, mainly because I think it was last year where we also covered this. A lot of students just didn't know that we had covered folic acid or thought we would just skip over this. I'm going to tell you that you do have like a multiple choice test question. So this is a slide that I want you to spend a little bit of time on, and I'm going to take you through a little bit of the important parts of this. So folic acid is this really interesting sort of vitamin, and we can take it as a supplement. And this folic acid, or vitamin B9, is a water-soluble vitamin. For those of you who know any individuals who've gone through like pregnancy, there's these vitamin supplements that you take. Most of the vitamin supplements that you take will also have a lot of folic acid because it's essential for DNA replication, and this vitamin B9 is essential for the synthesis and proper synthesis of proteins. If you lack folic acid or vitamin B9, it's been shown to result in a number of neural tube related birth defects. So not having enough in your diet or not having enough supplements causes neural tube defects as well as spina bifida and encephaly or inappropriate formation of the brain. And one theory behind all of this is that maybe one of the reasons why we have things like melanin is not just to help shade the DNA, but it's also to help make sure that any vitamin B9 that we have is to be protective and to stop the breakdown of any folate, because it's so crucial for normal DNA replication, synthesis of proteins. If you're exposed to sunlight, you're also breaking down this folic acid as well. So it's a theory that is out there, and there's, again, data to support that, yes, UV light, if it's not shaded by melanin, can actually be broken down in the cells, and without that, we start to see DNA misreplication going on as well. So again, a lot of interesting theories. It is a slide that you should make sure that you spend some time on. This is another important slide for you to spend some time on as well. Again, one of the things that is not great is I have a fairly good idea of when your your final exam is, and I'm trying to get you to start thinking about it earlier. Can't tell you exactly when it is because I'm not allowed to tell you when it is, but I can tell you should probably start studying earlier rather than waiting for it to be later on in the exam schedule. So if you were to go out, now you're all kind of like, when is it? I can't tell you, I'm sorry, but it is the way that it's currently, and it could change. It's a little bit on the earlier side, and I need you to start thinking about it being early and to start preparing early for it. So when we expose your skin to UV radiation, whether it's UVA A or UVB, exposure to UV radiation does cause DNA damage, both in the keratinocytes as well as in the melanocytes. So this is where we get basal cell carcinomas after exposure to too much sun, or squamous cell carcinomas, so those are all keratinocyte derived, different layers, or we get melanomas because of the melanocytes starting to accumulate DNA damage. This UV-induced damage from overexposure to sunlight might cause mutagenic photoproducts to start to develop. So photo or UV-induced byproducts that we can detect in the DNA. We can actually physically see signs of UV exposure within your DNA. And this primarily occurs within adjacent or side-by-side pyrimidine base pairs in the DNA to form what are known as cyclobutane pyrimidine dimers. And this is a signature mutation that occurs, and we know that you have had too much UV exposure. If this occurs in the wrong place within your DNA, so if, for example, this mutation and you form cyclobutane dimers within an area that contains like transcriptional elements, or if it's part of the p53 tumor suppressor and that DNA starts to form too many of these cyclobutane dimers, then you're running into some serious issues. So this produces the potential of having different types of mutations in either these keratinocytes or in these melanocytes. And it really depends on the types of these pyrimidine dimers that get formed, but this is the classic type that we are looking at, and I'll show you on the next slide which ones are more dangerous versus the ones that are less dangerous. So these types of pyrimidine dimers that potentially could form, and these are all pyrimidines, so they're side by side. We could form a thymidine-thymidine cyclobutane dimer. And this one, if it does form because you have like UV-induced damage, and you have not protected the skin cells appropriately, this one is not thought to be as mutagenic and therefore not as dangerous. If you had cyclobutane CC pyridine dimers, then this is thought to be much more dangerous for you if you accumulate them within your DNA. And this is thought to eventually cause the formation of either squamous cell or basal cell carcinoma. If it's in melanocytes and you start forming a lot of these dimers, then it might lead to melanomas as well. This is also a function not just of collecting these different types of mutations that are induced by UV radiation, but it's also a function of the DNA polymerase, what stretch of DNA that this mutation arises. And I'll be talking about this in the very last lecture when we work our way out of the skin module. So again, before we go through the last 2 or 3 slides, do you have any questions or things that you want to confirm now before we go on? Or any other, yes? So if we're looking at a sequence of DNA and it happens to be near a transcriptional regulatory element that might be really important for turning on or turning off other genes, if we had like the CC cyclobutane pyrimidine dimers happening there, it might be much more deleterious than if it's sort of in an intronic region of DNA. I don't know if that makes sense to you. Depends on the stretch of DNA. And one common place is within the P53, but we'll talk about that sort of in the last series. Did you have your hand up? Yes. Yeah, so I'm going to come back and talk about that sort of in the last lecture, but it actually affects the different repair enzymes a lot more, as well as how it will activate DNA polymerase. So it tends to have a slightly more activating and inactivating of the DNA repair enzymes and activating of like the DNA transcription. So it depends on where it's occurring. And I will come back and talk about that in the last lecture in skin. All right. So again, we have a lot of these different photo products, and one thing that I'll come back and talk to you about are these P53 pathways. And if there's damage to these P53 pathways, and we have DNA damage to these P53 pathways, then it becomes like a really serious issue. And what I'm also going to be talking about in the last lecture series, and I think, again, we'll talk a little bit about the melanocytes and the release of melanin and everything else. This last series of slides, which I'm not going to cover right now, and when we talk about the xeroderma pigmentosa and this XP molecule, Dr. Sidaway is going to talk a little bit about this. I'm going to come back and talk to you about this particular pathway. I'm also going to give you one of your questions on your final exam in advance in the lecture when I come back and talk to you about it, because it's a little bit different than what you had on your term test, and I don't want you to be really, really stressed out on your final, but it's more of an application base. So if I were to change one of these signaling proteins after we talked about it, what might you expect to happen in these different cell types? And I'll go through that with you. But just to give you a little bit of advance warning, this is an important slide that I'm going to go through in great detail in the last lecture. Dr. Sidaway will also bring this up in his lecture a little bit as well. And this gets into melanin, the production of melanin, the release of melanin, and all of the different pathways and the receptors that are involved. I think a few of you were asking if I would be able to provide transcripts of like the cell signaling pathway. Like, so if it interacts with the M1 receptor, what's sort of downstream of that, and how does that get activated? I will do so in advance of the lecture so you can review it and then make sure that you understand the pathway. And then we'll talk about a potential problem-based issue. And then we'll also come back and talk about some of the social justice issues related to how we understand skin cancer and why it's not always beneficial for everyone. So if you are not Caucasian or fair-skinned, what do the incidence of skin cancer represent for different individuals who are more tan or who have like different skin color profiles, and how do we address some of those differences, and how should we address some of those differences? So we'll talk about that in the next lecture. And I think we'll just wrap that up for today. Please make sure you're going to tutorials so you'll get a little bit of the most important parts of today's lecture. You'll have to start preparing for your final presentations. And there's things that you'll be doing in lecture this week. So I know you're all busy. Please make sure that you're not missing out on that lecture, that tutorial on Thursday, because it is a really important one. Have a great week. I'll see you all back here next Tuesday, and we will have our guest lecture. It will be recorded. We will have a transcript of the lecture as well. What do I have to do to stop this? Nothing? Do I have to stop anything?